What up, people? It is your boy, Mr. Noland. Alright, so today we are going to be classifying rational numbers on a Venn diagram. For you sixth graders, this is the first time you've ever seen this, so let's see if you can follow along. I'm going to start with a couple of real-life examples of what this would look like. Now, I don't know if anyone has ever seen those dolls where you have one doll, you take it off, there's a bigger doll, and then you take another off, take the lid off, there's another doll, and so forth. We're doing sort of like the same thing, okay? But here, let's start with this example. You have a small circle, and then that small circle is going to fit into a bigger circle. So that means everything in the small circle can fit into the big circle. But can the big circle fit into that small circle? No, it cannot. And then we're going to have a whole nother circle. And notice the two smaller circles fit into the biggest one. So you can go from small to large. But can you go backwards? Can the large ones fit into the smaller ones? No, you cannot. So here's an example that's social studies related. Let's say we live in San Antonio, Texas. Let's just say San Antonio. Well, San Antonio is part of the state of Texas. Well, I want you to think about this. Isn't Texas, the state of Texas, bigger than San Antonio? Well, yes, it is. But doesn't San Antonio fit into Texas? Well, yes, it does. Now, what does the state of Texas fit into? It fits into the United, if I can spell, United States of America. Well, is San Antonio part of the United States of America? Well, yes, it is. Isn't the state of Texas part of the United States of America? Well, yes, it is. Now, I want you to logically think of this. Can you take the entire United States, the entire thing, and fit it into San Antonio? Well, no, that makes no sense then. So again, you can go from small to large, but you cannot go from large to small. Now let's talk about it with math terms. So I'm going to draw my three circles again. In the small circle, we're going to have something called whole numbers. Whole numbers are your counting numbers, 1, 2, 3, 4, 5. But you also have to include 0. Is 99 a whole number? Well, yes, it is. What about 1 million? Yep, 1 million is a whole number. So there are no decimals allowed. Now I got a question. Can you have a fraction as a whole number? And that answer is yes. You can have a fraction as a whole number as long as it simplifies to a whole number. For example, 6 over 3, when you simplify that down, it's just 2. Okay? All right. Right next to the whole numbers, we have our integers. Integers are positive and negative whole numbers. So all we're doing is we're taking all of our whole numbers, 0, 1, 2, 3, and so forth. But this time we're doing their opposites. We also have to do the negatives. So like -1, -2, -6 over 2 simplifies to -3. Those are all examples of integers. And the last one we have are rational numbers. Our rational numbers are our whole numbers, our integers, plus decimals and fractions that don't reduce to a whole number. So, for example, 2.18. Well, that's a decimal. That's now a rational number. 1/4 is a fraction that cannot simplify to a whole number. That's a rational number. What about -3/8? Again, that's a fraction that cannot reduce to a whole number. Now, let's do one more example. And we're going to place numbers where they best fit. So on the test on Friday, there's going to be some questions on there that says, where does this number best fit? Does it best fit in the whole numbers? Does it best fit in the integers? Or does it best fit as a rational number? Also on your test, you're going to have to be able to label. This is rational numbers, integers, whole numbers. Okay, so let's give some example numbers. Let's say 0. Actually, let's do this. I'll just say it out loud. Where does the number 0 best fit? That means, like, where would it best start out at? Well, it best starts out as a whole number. So that's where 0 would go. Now, what about -3/2? So that's -3/2. Can that simplify to a whole number? No, it cannot. So this -3/2 goes to a rational number. What if we had -4/2? Well, that simplifies to -2, doesn't it? Well, that best fits as an integer. What about 1,000? The number 1,000. Where does it best fit? Best fits as a whole number. What about 1.75? You have the decimal, 1.75. It's a rational number. All decimals, except for a couple. I'll show you an example of a couple that will not fit there, but otherwise all decimals are in rational numbers. Now, what if you have this one, 3.0? Well, do you really need that 0.0? Well, no, you don't. So it's just the number 3. So that best fits as a whole number. What about -4.00? Again, do I need those those 2 zeros after the decimal? No, you don't. So it's really just -4, which best fits into the integers. So summing it up, whole numbers, just like your normal counting numbers, 1, 2, 3, 4, like when you're playing hide and seek, 1, 2, 3, 4, 5, but you also have to include zeros. Your integers are your positive and negative whole numbers. But if I ask where does it best fit, so if I ask where the number -3 best fits, it's going to be your integers. Let me rephrase this. Your positive whole numbers best fit right here. Your negative whole numbers best fit into your integers. Your fractions that cannot simplify to a whole number, or your decimals, like you see here, are your rational numbers. I'm going to create another video putting these into another Venn diagram. I hope this video helps. Guys, you do really need to study this and get some practice on this because this will be on your test. Alright guys, have a great day. Bye.